So in this problem, there is a rotating circuit. It rotates with a constant frequency. Along that axis. And it needs to find the induced current when needs to find induced current when the time is 0, and this rotating circuit is laying in XY plane. So to find the current, we can use the same induction law, using actually the Ohm's law. U is our resistance times current, the voltage, and then the induced together with this it becomes that so it's just combination of these three equations. It's Faraday's induction law on the top, in the middle of the page. So R is a resistance of the loop. So that's how we can find the current, dividing by the resistance, the voltage by resistance. So current can be found on voltage, and when you use voltage, we need to find the flux. And to find the flux, we need to find the magnetic field B. Sorry, magnetic field B is given in the problem. Yes, we just need to find the flux. The blue lines is a constant magnetic field in which the circuit is rotating. So, in this case, we don't have time varying magnetic field, but the time varying position of the circuit. So, since here's our flux equation. So let's start from the flux. The important is for rotating circuits that the normal is the normal of the surface is the same as the direction of the B field, so that the B field is perpendicular to the circuit to induce the voltage. So then we would have here the time changing normal. So for the case when the time is 0, the normal is in z direction, positive z. So let's calculate the flux. So our B is constant, is always in the direction. Our normal is time changing, and then we have some area ds. The dimension of the area not given, so it will be just some variable for the area, some constant. So that's what I have. And what can we do? We can find the scalar product of these two unit vectors, the normal and z. And the scalar product is multiplying their magnitudes, which is 1, times the cosine of the angle between them. So we would have cosine. What is the angle between z and normal? We are given omega in y direction, and this angle is usually omega t between. So for the time varying, it will be different in different time. So in the beginning it's 0, and then it can be 90 degrees, 180 degrees to 170. So it's cosine omega t. For the flux, then the next we can find the magnetic. From the magnetic flux, we can find the induction, the voltage in the circuit. Just write it here. Okay, so it's a time derivative of the flux. So B and S are constants, and then cosine omega t, and omega and minus omega t would be the time derivative. Not forgetting this minus for that it opposes the change. Okay. And here we have a minus from the time derivative from cosine. Okay, so we got a positive voltage, and now we can find the current from this equation. V divided by R. So that's the solution for the current flowing, which would flow at time So it would be the general solution, but at time 0, the sinus would become 1. So we would have the amplitude, this part was or at time 0, is omega 25 r. So from the simple equation, we can make a conclusion that to get high currents, the resistance should be small, the magnetic field should be large, the area, the circuit should be also large, and the speed should be quick, should have a fast rotation.